Today we're going to talk about coterminal angles and reference angles. Before we start, let's remember how to draw angles in standard position. Remember, you always start by drawing the initial ray along the positive x-axis. You can even start doing that for all four of these examples now. We always start going along the positive x-axis. That one's a little rough looking. There we go. Then we use an arrow to indicate the direction we want to go in. So here, this is positive, and so we're going to use an up arrow. Here, this is negative, so we're going to start by going down. Here, this is positive, we're going to start by going up. And here, this is negative, we're going to start by going down. And then we're going to put the terminal ray at the end of each of our angles. So if we want to make a 305-degree angle, I've already started that arrow in green. Let's keep it going. So this is 90, 180, 270, and then we won't go all the way to 360. We'll end up somewhere in here in the fourth quadrant. Is that perfect? I don't know, and it doesn't really matter as long as you end up where you're supposed to, which is that fourth quadrant. So that's what a 305-degree angle looks like. Negative 225, we start by going down, so there's negative 90, negative 180. We don't go all the way to negative 270, so we end up in there. That spiral's looking really rough. I think I'm going to resketch it. There we go. That's a bit better. So that's going to be in this quadrant right here. Now, 8 pi over 7 radians. That one isn't super available to us because we don't know our pi over 7 radians. We know things in terms of pi over 6, pi over 4, pi over 3. But what we can do real quick to think about it is remember that this is 0, this is pi over 2 or 1/2 pi, this is 1 pi, and this is 3 pi over 2. And we can think about what does 8/7 represent? Well, we know that 7 over 7 is 1, so that would be 1 pi, and 8/7 is going to be a little bit more than that. So if we're going a little bit more than pi, then we're going to end up going right here. And that is what 8 pi over 7 looks like. 7 over 7 is 1, so 8 over 7 is a little more than 1 pi. Last one, we're going to do negative pi over 4 radians. Well, we know positive pi over 4 radians is the same thing as 45 degrees. So negative is going to be negative 45 degrees. So we're going to go down, and then our angle looks that way. So this is just a review of angles in standard position. Again, the initial ray is along the positive x-axis. And then we go arrows up or down for positive and negative, and then the terminal ray is the ending side of the angle. So we're going to learn a new vocab term, and that is coterminal. Two angles in standard position are considered coterminal if they share a terminal ray. Think about the word co or the prefix co. Like a co-captain, you share being a captain. It means with. So coterminal means they share a terminal ray. So to end up in the same position, a ray must be rotated in a full circle. It doesn't matter where it starts because if you go in a full circle, you're going to end up in the same position. So a circle is going to be 360 degrees or 2 pi radians. So here's an example. Find an angle coterminal with 305 between negative 360 and 0. So 305, let's start by sketching it. We always start with our initial ray in standard position. And then 305 means we go 90, 180, 270, and a little more. So this is what 305 looks like. Now, if we want to go between negative 360 and 0, do we need to add a circle or subtract a circle? Well, to get 305 lower than 0, we need to subtract a circle. So here's what we're going to do. We're going to start here at our terminal ray, and we're going to make a coterminal angle, which means they share that terminal ray. So we're going to go backwards a full circle. How do we think about that mathematically? Well, we started at 305, and then we went backwards a full circle. We subtracted a circle. 305 minus 360 is negative 55 degrees. Does that fit between negative 360 and 0? Yep, you bet negative 55 is in the middle of those. So we started with 305, and then we subtracted a circle to get to negative 55. Technically, you can add or subtract circles forever and keep getting coterminal angles. We could start at 305 and add a circle and add another circle and add another circle, or we could subtract a circle and subtract and subtract. There's an infinite number of answers. But this question asked for one between these two values. Let's try another one. We're going to start with negative 225. So negative 225, we go negative 90, negative 180. We don't go all the way to negative 270. We're right in here. And we want a coterminal angle, so we can add or subtract as many circles as we want. We are going to try to get between 360 and 720. So let's add a circle to it. Let's start at negative 225 and go and add a circle to it. Ignore that weird stray mark. We went, you got to make the noise, and add a circle to it. So negative 225 plus 360. Is that going to get us between 360 and 720? Nope, that's not going to get us there. But the good news is we can add as many circles as we want. So if we add another circle, then we will end up with 495 degrees. And does that fit in this range? Is that between 360 and 720? You bet it is. So again, we add or subtract circles to find a coterminal angle in the range described. So this one uses radians. We're going to use 8 pi over 7, and we graphed 8 pi over 7 above. 8 pi over 7 is a little bit more than pi, so it's right here. And we are going to add a circle to get between 2 pi and 4 pi. So we're going to add a circle. So 8 pi over 7 plus 2 pi. Now, if you're not sure how to add these together, what I suggest is just look at the fractions and add them together. You can do 8 over 7 plus 2. And if you put that into Desmos or whatever graphing calculator you prefer, then you will get 22 over 7. You can even change that to a decimal to make sure that it's between 2 and 4. But don't forget, just because you simplified those fractions, you can't just get rid of pi. We got to put pi back in at the end. So we're going to get 22 pi over 7 radians. And we did that because we added a circle. This next one, we've got negative pi over 4 radians is right here. And again, we can add or subtract as many circles as we want. Since our goal is to get between negative 4 pi and negative 2 pi, we want to subtract. So we're going to go backwards a full circle. So negative pi over 4 minus 2 pi. Again, use your favorite graphing calculator like Desmos or the TI-84, and you'll do negative 1/4 minus 2, and then you'll get a fraction as your answer. If you get a decimal at this point, I hope you know how to change it to a fraction. You'll get negative 9 over 4. And then don't forget, that pi needs to go back at the end. So negative 9 pi over 4 radians. So we've talked about coterminal angles. If you add or subtract a circle to an angle, you'll end up in the same location. But there's one more type of angle we're going to talk about. So coterminal angles we've taken care of. We add or subtract a circle. Reference angles, that's a different vocabulary word. And reference angles are called that because they're easy to refer to. So remember when we were building our unit circle and I told you that you only had to memorize things about these three angles. If you know that this is 30 degrees, if this is 45 degrees, if this is 60 degrees, and then the radians, pi over 6, pi over 4, pi over 2, nope, just kidding, pi over 3, and then the coordinates, 1/2 root 3 over 2, root 2 over 2, root 2 over 2, and root 3 over 2, 1/2. The reason that you only have to memorize these is because you can use these angles and use the triangles they come from to find other parts of the unit circle. So if I say, hey, what's this? You can refer to the angle in the first quadrant. So everything in this first quadrant between 0 degrees and 90 degrees, we call these reference tools because you can use this information to build something over here, down here, or over here. So reference angles are always between 0 and 90 degrees. They always live in the first quadrant, or 0 and pi over 2 radians. So in order to find a reference angle, we find the difference between the angle we're given and the x-axis. Another way to think about it is we're creating those triangles. So a hint is think about your bow ties. Here's how it works. If we sketch 305 degrees, remember we start with our initial ray. We go around the circle, 90, 180, 270, a little bit more. This is 305 degrees. We're going to find the distance between the given angle and the x-axis. In other words, we're going to make triangles just like we did when we built the unit circle. So here, the triangle that this makes is this triangle right here. So the reference angle comes from reflecting that triangle into the first quadrant. How do we know the measure of that angle, though? We're looking for the measure of this angle, so we're looking for this value. Well, we can do that by finding the measure of this angle down here, because they're the same angle, it's just reflected. If we're at 305 right here, what is the distance from 305 to the x-axis? If we know the x-axis is 360 degrees, then that angle distance is going to be 55 degrees. So if this distance is 55 degrees, then we know that our reference angle is 55 degrees because these angles are the same. So again, I know that's kind of tricky. Let me explain it one more time. 305, if I don't draw the little arrow, I just want to draw where it ends up. I'm going to get rid of the arrow. 305 is right out here, right? If we make a triangle out of that and reflect that triangle up into the first quadrant, if we know this angle right here, we can then know our reference angle. Remember, reference angles always live in this first quadrant. So the distance from 305 to the x-axis is 55 degrees. Then we know that this is also 55 degrees. This next one, negative 225, if we graph it, we start with our initial ray. we go 90 degrees, 180 degrees. We don't go all the way to 270. We end up right here. Now we want to figure out our reference angles. So we always find the distance from the x-axis. That's how we make our triangles. So we're going to drop a perpendicular line right here, and we've made a right triangle, and we can reflect that triangle to help us find our reference angle. So we need to know this angle right here. Well, if we know that this is negative 225 degrees, and we know that this is 180 degrees, we can find the angle measure of this right here. Oh, sorry, that should be negative 180. It honestly doesn't matter too much because we're looking for this angle measure. How far is 225 from 180? It's 45 degrees, meaning our reference angle right here is also 45 degrees. The same thing is going to be true for radians. This is what 8 pi over 7 radians looks like. We know that this is 7 pi over 7 radians, right? Because 7 over 7, that's just a fancy one. That's really just pi radians, right? So this is 7 pi over 7 radians, the x-axis, and then we make a triangle out of it, and this is 8 pi over 7 radians. What's that angle measure in radians? How far apart are they? 8 pi over 7 radians minus 7 pi over 7 radians. You can think 8 over 7 minus 7 over 7. It's 1 over 7. So this angle is pi over 7. So if we reflect that triangle up into the x-axis, this is also, or the x-axis, the first quadrant, this is also going to be pi over 7 radians. And then finally, negative pi over 4 radians. Oh, I used a different color. Not a big deal. All right, if we do negative pi over 4 radians, and we want to make a triangle out of that along the x-axis, what's this angle measure right here? Well, we know that this is a distance of pi over 4 this way, so the reference angle is going to be pi over 4. So the reference angle can always be found by reflecting the angle into the first quadrant. So I'm going to explain this one more time just so you can see it in a different way. 8 pi over 7, we know that that's out here. I'm going to erase everything else. And then I'm going to use our bow ties that we've been doing when we built our unit circle. The reference angle is always the angle out here in the first quadrant. So if we know this angle right here, then we know this angle right here. And if we can find the distance, in this case, it's pi over 7, then we know this distance is also pi over 7. Here, same thing. If you want to think about it this way, if it's helping. If this isn't helping, then you can stop the video and think about it the way you've been thinking about it. Negative 225, we go negative 225 is out here. I'm going to erase everything else, and then we're going to make a bow tie out of it. The reference angle is always in the first quadrant. So if we can figure out what this is, then we automatically know what this is. This distance right here from the x-axis is 45 degrees, and that means our reference angle is 45 degrees. All right, I hope that helps.